Oh boy, I know you're as excited as I am, and for exactly the same reason. I'm about to talk about something cold and stony and dead, and that always lifts my spirits and makes my jaded old heart sing. I've got my sights set on petrified wood because that stuff is all over the place and I hear its siren song constantly, which is why there's so many tons of it at my house. In this video, I want to talk a little about the process of petrifaction, the taphonomy involved, and the course that takes over the life of a specimen, and show you some photos of petrified wood that I've collected from hither and yon. The technical information I'll share with you comes from Neil Sunnison's Petrified Wood in Oklahoma, a PDF copy of which is available online at no charge from the Oklahoma Geological Survey. As you can see, it's a reprint of an article published in the Shale Shaker in 2010, and I thought we'd first take a look at the photos in the article, starting with the two on the cover. This one is a specimen of unknown genus from the Pennsylvanian age Nowata Shale near Jinx. The longest dimension on the top is 13 inches, so that's a considerable chunk of petrified wood. Sharing the cover with that piece is one from right down the road, a 20-inch long specimen of probable Didoxylon adaense, collected from near Kerr Lab from another Pennsylvanian period formation, the Wewoka. Just look at those vascular bundles, beautifully preserved in this silicified specimen. The photographs in the publication are from all around the state, and I did some cutting and pasting for purposes of enlargement. First, we have a petrified log from the Post Oak Conglomerate in Tillman County. The Post Oak Conglomerate is a Permian age formation that accumulated in the lowlands around the Wichita Mountains at the time they were being carved, and before the hole was inundated in the great subsidence that made central Oklahoma a shallow sea during the late Permian. Actually not so shallow in the case of the nearby Anadarko Basin. Next to that photo is something that I know a good many of you have seen, the petrified wood log jam at Camp Goddard. There's a nice view of it from the balcony outside the Children's Museum. This material comes from Cretaceous deposits in southwest Arkansas, but it's the same great sweep of the Cretaceous exposed all over northeast Texas and southeast Oklahoma. And anywhere you find estuarial deposits of that age, you'll find petrified wood. Next up are some pieces from the Permian period Garber Formation, which covers a vast swath of central Oklahoma, and next to it a petrified stump in front of the Midgley Museum in Enid, probably from the Ogallala Formation and therefore of Miocene age. That stump looks silicious to me, while the pieces from the Garber, collected in Grant County up near Kansas, are replacements by minerals of iron oxide and copper. There's a fantastic range of types and states of preservation of petrified wood, and I'll be touching on some of that. To the left is a photo of stream-transported petrified wood gravel from the General Materials Quarry in Oklahoma City, a site we visit regularly. That material answers to the description of petrified wood most commonly found in Oklahoma, distally transported rocks that can only occasionally be placed with certainty in an identified formation upstream. Since the Canadian River flows mostly through rocks of Paleogene through Permian age, one can assume that the petrified wood quarried at General Materials is from some time during that span of years, but a 200 million year time period can't be said to have narrowed down the possibilities usefully. This is the stuff I pick up just because it's fun, not because it's particularly informative, ornament rather than useful data. To the right is a piece found right up the road near Francis, embedded in another Pennsylvanian formation, the Holdenville. Here we have a photograph of what is possibly the first true wood on the planet, and it's from near here. This is Calixylon from the Devonian period Woodford Shale. Calixylon is the name given to the wood only of the long-extinct genus Archaeopteris, not to be confused with the late Jurassic period bird Archaeopteryx. Be careful how you pronounce those. Archaeopteris became widespread during the late Devonian. I have some pieces in my collection to show you, and I must confess great affection for it, it was in all likelihood Calixylon Archaeopteris, or something very much like it, that made you and me possible, along with much else that I love and cherish. I think I'll leave that enigmatic statement hanging there and return to it after I've distracted you for a while. On the right is some petrified wood from the Arkansas Novaculite, a formation in the Ouachita Mountains exposed south of Wilburton. Unless this wood can be identified to the genus level, I'm thinking that about all one can say about its age is that it's Carboniferous. Here's some petrified wood colored by copper minerals found near Pawnee at the base of the Matfield Shale, a Permian-age deposit, here embedded in a conglomerate such as you often find at the base of formations, especially where an erosional unconformity is involved. And over to the right is some petrified wood put to decorative use at the Roberts Ranch near Kenton, big silicified logs from the early Cretaceous. The last photos in Neil's article are of a house in Lexington that I'm sure many of you have seen, a building constructed almost entirely of petrified wood shipped in from some location in Texas. And to the right, the author himself standing next to a familiar Ada landmark on the campus of East Central University. Here's a map of some areas where petrified wood can be found in situ, and of course, as I mentioned earlier, you can find it in weathered condition as stream-transported gravels and cobbles in floodplains, modern and ancient, all around the state. Of particular interest to yours truly are those in situ deposits near Ada, which include instances of Calixylon. Since I'm going to talk about petrifaction, here's how the American Geosciences Institute defines it: a process of fossilization whereby organic matter is converted into a stony substance by the infiltration of water containing dissolved inorganic material, for instance calcium carbonate or silica, which replaces the original organic materials, sometimes retaining the structure. Here are some photos of a piece I collected near Gallup, New Mexico that illustrates very well what that definition promised. Despite the relatively low resolution of photos made with my cell phone, you can clearly see a great deal of structural preservation in this piece, rotated here to show all four sides. The majority of petrified wood found in Oklahoma is silicified wood, and much of it thus takes a high polish and has in earlier times served as material for tool manufacture, as it fractures in much the same way as chert. That's also why you'll find so much of it in stream beds and floodplains. Quartz is hard and can survive a long, brutal journey downstream. Now to the process of petrifaction illustrated in this schematic from the Sunnison article. When petrifaction involves silica replacement of organic material, the process is known as templating, and this drawing illustrates the continuum. To the left is the material to be replaced at the cellular level. This is how vascular bundles are preserved in petrified wood, and as you can see, reading toward the right, that is an ongoing process that eventually destroys the cellular structure that one might wish to examine. You have to catch it at the right time in its life in order to have optimal conditions for study. There's also so-called fossil wood, casts and impressions of wood. To the left is a schematic that illustrates the process. As the air and water are forced out of a buried limb by the pressure of accumulating sediments, the encased limb is gradually flattened and in extreme cases can end up as nothing but a smudge of carbon with an impression above it. Intermediate states of preservation are common, and I have a few pieces to show you that illustrate that very well. In fact, the fossils of calamites one finds in the Pennsylvanian formations of the Ouachitas are mostly casts and impressions. The figure on the right illustrates the formation of molds and casts of fossil wood, again different from petrified wood in which the structure of the wood is preserved in molecule-for-molecule mineral replacement. Fossil wood, by contrast, is an infill, not a replacement. If the encasing sediments are tightly enough integrated, that is, well on their way to lithification when the encased limb decays, That leaves a void that can later be filled by sediments or minerals, and if that structure later weathers out of its matrix, you have an impression of wood, but not actual petrified wood. There's plenty to learn about petrified wood, and this has been only the most superficial of introductions. Indeed, I've only scratched the surface of Neil's article, and I would encourage you to pop over to the OGS website, download it, and read it. Now I want to show you some pieces from my collection, petrified wood that I've collected from well over 1,000 miles of North American geography, most of it from Oklahoma. I'm going to start close to home and then go sallying forth and finally return to nearby locations, kind of like an ABA form musical composition, starting here, going there, coming back here. The first pieces come from just a few miles south of here, at the access, such as it is, to Clear Boggy Creek off the US 377 bridge and right-of-way. That area is not as fully accessible now as it has been in the past owing to recent fencing, but there is still a portion coterminous with the highway right-of-way that's sufficiently supplied with gravel bars to be worth a visit. It'll take some clambering to get down to the creek. I've collected material ranging in age from the Devonian to the Pleistocene along that short stretch of creek, and here's some of the Calixylon I've gathered from there. This is extremely hard, dense, cherty petrified wood with good preservation of some of the vascular features and surfaces. I'm sure it would take a beautiful polish, but I no longer commit lapidary. I want to return to something I left hanging earlier, something about Calixylon, this early wood, from one of the first woody plants on the face of the earth. These early trees, growing in estuaries along the edges of continents, provided the shade that was necessary for vertebrate animals in an amphibious condition to venture forth onto land, even if just barely. The earliest tetrapods, just getting their start during the late Devonian, weren't exactly amphibians in the sense we think of amphibians today, but they were amphibious, and they had not yet developed amniotic eggs, which meant they still had to lay their eggs in water, just as modern amphibians do, and were as tied to water as their modern counterparts are, their young hatching underwater and spending the earliest part of their development like clumsy fish before being equipped with the necessities for terrestrial life, and even then they have to stay moist or their skins desiccate, never venturing from the shade of the swamp with the exception of a few toads that have grown tougher skins. It was those early trees, like Archaeopteris, of which Calixylon is the constituent wood, that put vertebrate life on the road to a fantastic terrestrial adventure that's included some of the most unlikely critters you could possibly imagine, with the most unlikely of all, without a doubt, being us. Calixylon gave us our start. Calixylon is not by any means the only petrified wood one can find along Clear Boggy Creek. Here are specimens that might be representative of any number of time periods. I would describe this material as, in some cases, not certainly Calixylon, and in others, certainly not Calixylon. Here also, from Clear Boggy Creek, is some fossil wood impressions, as discussed in Neil's article. Some of these are almost flat. Now let's go far afield. I won't take you as far as the Mojave Desert in California, where I've collected petrified palm, and I've already shown you this handsome specimen of unknown genus from a canyon near Gallup, New Mexico. So I want to begin this visit to faraway places with some remarkable pieces that I've gathered along the Rio Puerco, about 20 miles west of Albuquerque. These are thoroughly silicified pieces with a wide range of colorization by accessory minerals. And what my cell phone can't begin to capture is the glossiness of all these specimens, although every now and then the angle's just right and you can catch a glimpse of what's true of all of them. They've been lying out there in the desert for hundreds to thousands of years, taking the brunt of fine wind-blown particles of quartz, feldspar, and whatever else those constant winds churn to dust, those rocks being scoured and polished more efficiently than any rotary tumbler ever could, turning every surface lustrous. A good many of these pieces show translucence along broken edges, and there are a few smaller pieces that are completely transparent, although that feature really isn't easy to appreciate in photos taken against a black background. That piece in the upper left is apparently a petrified root, and it's one of the transparent pieces. Closer to home is a public area along the Canadian River about 15 miles north of Amarillo, accessible from U.S. Highway 87. The areas of interest are eroded banks on the south side of the river cut by gullies that are seasonal tributaries of the river. Along some of those tributaries there are small slot canyons, and in some of those the in situ specimens are beautifully preserved and not particularly plagued by the coating of caliche that is typical of much of the material from that area. That collecting area is also rich in alluvium, which means that quite a range of specimens comes from there, and I'll start with some of the pieces that have been distally transported, beginning with this striking boulder of beautifully preserved silicified wood. I'll rotate this one so that you can get an idea of what it actually is. Here are some pieces that are representative of that distally transported condition, and as you can see, some of these pieces have made a long journey and have taken quite a beating. Others have been moved just a little and still retain quite a bit of their detail. I believe you'll detect a range of silicification in these pieces. I once tossed a few of the smaller rounded pieces into the tumbler, and the results were not surprising. These mostly exhibit the gloss that's typical of thorough silicification. Those pieces that have not been moved so far, and thus have been subjected to less of a beating before coming to rest, come in a great range of sizes, quality, and conditions. In every case, I'd predict that thin sections of most of this material would tell you quite a bit. My collecting buckets got heavy from time to time. Here are some pieces found in situ, or nearly so, and these have been percolating for a long, long time, such that any opal that might have once made the cellular structure easily visible to thin section microscopy has completely disappeared under a welter of small quartz crystals and perhaps something else. There's obviously a lot of iron oxide involved in these pieces, and I wonder about some of those minerals. I believe I need a geochemist to weigh in on these for me. Earlier I mentioned small slot canyons that are worth poking around in. It's there that I found some of the best specimens, and here are a few photos of those. This material is pretty close to pristine, although it does look as though the petrifaction process is extremely advanced, and it seems unlikely to me that any of the cellular structure is still visible. There are some big pieces among them. This wood appears to have been petrified pretty much where it grew and fell. To judge from the geologic map of Texas, this material is of Upper Permian age, and I may have shown you a fifth of the material I've gathered from that site, a couple of square miles of badlands that have eroded a great deal since I've been there and are no doubt flush with new specimens. If you need a map, I'll be happy to draw you one. Working our way back this direction, here's some petrified wood that I picked up in Greer County along the Elm Fork of the Red River north of Altus. There's a great range of types of wood and strategies of preservation among these mostly thoroughly silicified specimens. Deep reds are common in the coloration, and there are also a few transparent pieces. Let's take a look at a few. In this photo, I've also included some bagged fragments of fossilized bone from those sites. Since this alluvium has been transported from somewhere near the headwaters of the Red River, and the river and its tributaries are at that point flowing across Triassic period sandstone but cutting down into earlier Permian material, these bone fragments are probably from animals that lived around that time, between 200 and 300 million years ago. There could, in other words, be some fossilized remains of those early cynodonts, Chapter 1 in the Evolution of Mammals. Some of this petrified wood exhibits really fine conservation of vascular structure, and here's a piece that's so much like chert in its conchoidal fracture that I think it may have had a piece knocked off it for making a tool. I've also polished a few pieces, and their thoroughly silicified condition has yielded lustrous results. I've shown you maybe half the petrified wood I've gathered out in Greer County, and I think a visit would be worth your time and gas money. It's pretty easy to get access to the riverbed and surrounding road cuts if you're out that way. Now I want to turn my attention to some material closer to home. Do you remember this photo from Neil's article? This is petrified wood gravel from the General Materials Quarry in southwest Oklahoma City near the Canadian River. I wasn't exaggerating when I used the archaic English measure tons in describing my holdings, for the petrified wood I've gathered at that one site alone would come close to qualifying as a ton or more. If you watch my videos, you've seen bookshelves filled with beer cases in the background. While it's true that I consumed every single bottle of that delicious stuff and enough to fill dozens more such cases around my house, those boxes are now filled with rocks, fossils, and minerals. I took one box of petrified wood gravel from General Materials that I've tumble polished and divided it into 5 camera-friendly piles, and I'll show you those. Most of this material is highly silicified and takes a mirror-like polish. There's a fantastic range of petrifaction and also of species, representative no doubt of a vast time period, including numerous geologic epochs preserved in the sedimentary beds that the Canadian River runs through. Alluvium just doesn't tell you much in the way of specifics, but a lot of it sure is handsome, and I find it irresistible. The annual General Materials trip is one you don't want to miss. There's also the petrified wood I've gathered around Lake Thunderbird, far more than I've collected from that site near Amarillo, as well as that petrified wood that can be found in great abundance in the Vamoosa Formation along with the Boley agates, and the petrified wood from the Byers geode sites and the Ouachita River, and petrified wood of Cretaceous age that can be gathered all around Lake Texoma. I have numerous boxes of all the material I've just run through, and by this time you've seen so many low-resolution photographs that I fear it may all be running together in your mind. So I'll finish with some shots from 2 sites that we visit with fair regularity. First are some pieces from the Byers geode site. This is a Permian site, and the alluvial petrified wood found in what must have been at times a riverine environment is presumably of the same age. Neil's article makes the claim that no silicified wood of Permian age has been found in Oklahoma, but I'm wondering about these pieces. Since they show no response at all to the usual acids, I've concluded that the replacement material must be silica, and have thus come to think that either Neil was referring to Permian material found in situ in the state rather than as alluvium, or to regard silicified and replaced by silica as a distinction that perhaps represents a real difference. Paleontological terminology can be confusing to this old musician from time to time. The petrified wood from this site is plentiful, but for the most part it all looks similar, much of it apparently identical. Of far greater interest at the Byers sites is another type of plant fossil that doesn't fall within the purview of Neil's article, but whose taphonomic history is similar to that of the fossil wood described therein. These are fossilized stems of estuarial plants, presumably from the Permian period. Some of these are concretions of iron oxides, lustrous hematite in some cases, I suppose, others being more like goethite or limonite, rather lackluster. These fossils formed in swamp sediments, which are always rich in plant detritus. When parts of dead plants fall into a swamp and sink to the bottom, they typically come to rest in acidic, oxygen-poor conditions, and decay is thus much retarded since anaerobic bacteria work slowly. It's not unusual for a plant stem to retain its full shape long enough to be covered in sediments, and given enough accumulation and sufficient hardness of the plant material, a near void can over time be created in a sedimentary deposit, a near void in which an infill fossil of this sort can form. Bog iron concretions typically precipitate out of water around a nucleus of some kind, and a shriveled plant stem inside a void left by the shriveling can provide just such a nucleus. The iron oxide precipitates around that desiccated remnant, filling the emptiness left by prolonged decay, and when that vegetable remnant too decomposes much later, it leaves a tiny cavity running from end to end of the specimen along its length. That's true of many of the pieces you see here. The same conditions will also preserve leaves. I've selected just a few from buyers, hoping that these are sufficiently viewable in this photograph to make them at least representative, if not interesting. There are quite a few genera of ferns represented here, apparently. The fossilization process is much the same as I described for the stems. A nodule of hematite or other iron oxide forms around the leaf or frond, and when that nodule is later subjected to the abuse of stream tumbling, it's likely to split along the plane of weakness where the plant frond once was, leaving the positive and negative sides of an impression to be picked up by some lucky collector like yours truly. The buyer's sites are nearby, only one of them open to us at present. And our annual field trip there is always a productive pleasure, even though it involves walking through a quarter mile of often high, wet grass. I'm going to finish with a few pieces I've liberated from the Boley Conglomerate of the Pennsylvanian Age Vamoosa Formation. Much of this material comes from the section line roads in the vicinity of Sasakwa. A lot of those roads are surfaced with gravel quarried in the area, with plenty of petrified wood showing up in the bar ditches alongside the roads, especially after rains. Here and there are beds of intermittent streams that one can get down into, and it's not uncommon to find lots of petrified wood in those. Of course, this is also where the Boley agates are found, and the petrified wood, typically highly silicified and interesting in profile, is a bonus. I have tumble polished a little of this material as well, and it has also yielded well to that treatment. Surely that's enough to either whet your appetite or put you off petrified wood forever. It's about the most widely available fossil type in Oklahoma, representative of a wide range of geologic eras from those earliest true woods during the Devonian to quite recent Pleistocene material in some of the floodplains. And if you don't yet have tons of it at your house like I do, maybe you need to get started.